Okay, question 7. This seems to be a fairly popular type of question. So if you understand how to produce these general equations, this is a good mark collector, if you like. It's not a terribly difficult question if you've practiced some. So it says on any day, total cost of the factory Y of making bars of soap is modelled by a fixed cost. So the cost of the factory Y is some fixed cost, let's call that C, and then a cost that's proportional to the number of bars of soap that they make. So the number of bars of soap that they make is X, so it's going to cost them some money per bar of soap. It's just a Y equals mx plus C equation. So it's proportional to the numbers of bars of soap that they make plus some additional fixed cost per day. It says the bars of soap are sold for £2 each. On a day where 800 bars of soap are sold, the factory makes £500 profit. On a day where 300 bars of soap are sold, the factory makes a loss of £80. So if we look at the 800 bars, if we look at that day, if it makes 800 bars of soap and sells them for £2 each, then it's going to collect in £1,600. But obviously there's a cost involved in that. So the cost involved must be the £1,100 that they don't receive in profit, because they're not getting £1,600 profit, they're only getting £500 profit. So this must be the cost to the company to make those 800 bars of soap. So if it costs them £1,100, we can use our Y equals C plus KX equation again, that we said that it will be the fixed cost that we don't know, plus 800, X is the number of bars, so 800 for X times that K value, times the cost per bar of soap. If we do the same thing for the 300 bars, then we know that they're going to collect in £600, but it says that they make a loss of £80, so it's going to cost them, it must have cost them £680 to make those 300 bars of soap. So if we do a similar thing here, the £680 is the fixed cost plus the cost per bar. So that's going to be 300 times K this time. We need to work out C and K. We've got a pair of simultaneous equations here. We need to find out C and K. I can make C the subject of both of these. So C is equal to 1100 minus 800K. C is also equal to 680 minus 300K. And we can solve this pair of simultaneous equations. So 1100 minus 800K is equal to 680 minus 300K. If I add the 800K onto this side, that's equal to 1100. Take away the 680. That's 420. So K, the cost per bar of soap, is 420 divided by 500, which is 0.84. We can then go back and find C. Doesn't matter which equation I use, I'll use this bottom one because I can see it. C is equal to 680 minus 300 times 0.84. Which is 428. So it costs £428 per day plus 84 pence per day to make the bars of soap. If we put that together, that gives us that y is equal to 428 plus 0.84 times the number of bars of soap. And that's exactly what they were looking for the answer. Okay, part C, it says with reference to the model. So that means you need to give a context to the situation that's going on. You can't just say it's the gradient of the line. The significance of the 84p in the equation, that is the cost of making 1 bar of soap, apart from the fixed cost. Okay, for part D, it says then, assuming that every single bar of soap is sold, that's important, find the least number of bars of soap that must be made on any day for the factory to make a profit. So we know that, so say they sell X bars of soap, we know that they will get in £2 per bar of soap, so they will make 2x pounds input. That will come into them. However, they then have to minus the cost. The cost of the soap is that y equation. And in order to make a profit, the 2x coming in needs to be greater than this y. So that sum needs to be bigger than 0. That's the profit that they will make. So if we substitute the y in for the actual equation that we found for y now, which was the 0.84x plus 428, and solve that, we're going to get 1.16x minus 428 needs to be greater than 0. 1.16x needs to be greater than 428. So x is going to need to be bigger than 428 over 1.16. Which is 368.9 bars of soap. $368.9. So least number of bars is going to be 369 bars of soap.